Okay, so this week we will look at hypothesis testing in detail, and we started this topic out last week, but today we'll actually look at it in a bit more detail. Note that this is also the last week of classes, so this is a topic which officially will be covered in the exam, but we'll only be looking at very simple things. So don't ignore it, but again, this is a fun topic, so hopefully you will find it interesting. Okay. All right. So what is hypothesis testing? Right. So this is something that we saw last time, and so today we'll go a bit more into detail into this notion of a Fisher test, and we'll also introduce this key notion, which is kind of very important for hypothesis testing, which is called the significance level of a hypothesis test. Okay. So that'll be the agenda for the day. And actually, this is all we will mainly cover about hypothesis testing. There's this very useful other notion called p-value, which we'll not cover, but it's quite related to the significance level. Okay, so I'll mention a few words on that towards the end. Okay. So what is hypothesis testing, right? So as I said last time, so this is one of the most common applications of statistics, and in fact you'll see some form of hypothesis testing appearing every day in the newspaper almost, right? So one canonical example, which I guess started this field, is this question: does smoking cause cancer? And there have been parodies of this, like I posted this XKCD comic. Few days ago, like I was saying, there was this study that conducted saying, oh, does air pollution correlate with the coronavirus? Right, so you see this sort of thing basically every day in newspapers, right? So this is really a very important aspect of statistics. And one thing I said this last time, but I'd like to stress more, is that statistical methods can never tell you anything about causality. Okay, at least the kind of things that hypothesis testing does, right? So it does not tell you anything about causality. Like if I ask you, does smoking cause cancer, just statistics is not going to be able to answer this question, but it's going to tell you something very useful. It's going to tell you the correlation, okay, and it can also tell you if there is what is called a statistically significant correlation. Okay, and so that's the goal of hypothesis testing. Right? So we'd like to see if there are significant correlations between the things of interest. Okay, and again, this does not tell you that this is a cause, but it gives you some evidence that, oh, okay, these two are correlated more than what you would expect in some random setting. Okay, and that's what we will try to formalize today. Okay, so here's the origin story, right? So I told you that that the notion of hypothesis testing was introduced by this guy called Ronald Fisher, and the basic question was. So he was studying various things, but at least in the introduction of his book, he starts off with this very simple example about him being at a party, and so there was a lady in the party who claimed that she could tell if the teacup, if tea was made by first pouring milk into the teacup and then adding brewed tea, or if brewed tea was first added, or something like that, and then milk was added. Okay, and it seems like one should not be able to tell the difference between these two, but she claimed that she was able to tell the difference, and and then Fisher came up with a test, right, and where or an experiment where he had 4 cups that were made using method 1, 4 cups using method 2. Sorry, let's call them method A and B, because that's the notation that I'm going to use later. Okay, method A and method B. Okay, and he knows, of course, what the true labels of these cups were, and then he permuted these cups in random order, presented them to the lady. Okay, so that's the experiment. Okay, So in hypothesis testing, how you phrase the experiment can often be something of importance, right? So that's why Fisher's original book is called The Design of Experiments. Okay, so it's although of course in the examples that we will see, the experiment itself will be somewhat natural, but that could make a big difference. There are areas like agriculture and so on where it's important to do the right experiments. Okay, so anyway, so in this case, this experiment consisted of just like 4 cups using method A, 4 cups using method B, and they were randomly permuted and presented to the lady. Okay. Okay, so the second kind of a hypothesis, right? So suppose I give you a coin and I claim that it has a bias. Okay, I tell you that the probability of heads is actually more than 3/4. Okay, and now you can ask, okay, so what is the experiment that you're going to do? Right, a natural thing to do would be to do a certain number of tosses, let's say 10 or 20, and you try to see how many times you ended up with heads. Using that, you may want to decide whether this hypothesis is true or not. Okay. So this is an intuitive kind of an introduction to hypothesis testing. Right? So how do you now make this formal? Right, so it turns out that the right way to make this formal, or a very good way to make this formal, is as follows. Okay, so the idea is to formulate 2 hypotheses. One is called the null hypothesis, and the other is called the alternate hypothesis. Okay, so the null hypothesis often can be viewed as, you know, a pessimistic viewpoint. Okay, so it is often going against the claim that we would like to verify. Okay, and it does not strictly have to be so, but usually that is the case. Okay, so in the first example, we say that, okay, so what is the null hypothesis? So this says that, you know, maybe this claim was false, right? So in this case, the null hypothesis would just be the lady is just guessing. Okay, which just means that probability of getting any single query correct. By query, I just mean she sees a cup, answers it correctly, is 1/2. Okay, so that's the null hypothesis, and the alternate hypothesis is pretty vague over here. So it's just saying that the lady is not just guessing, right? So ideally, you might want to say something like, okay, the probability of getting a query correct is more than 1/2. Right? So here I'm not saying that. It could be less than 1/2, and still the alternate would hold. Okay, but the point is that that does not really matter. So the null and alternate are things that we define. Okay, at least from a statistical standpoint, these are just mathematical notions that we define. Okay, so now the process of hypothesis testing works as follows. Okay, so which is, and this is a very general process. So you formulate the null and the alternate. Okay, then you perform this experiment. Okay, and this experiment in this case will tell you, okay, so how many correct or something like that, and then you measure some test statistic. Okay, which is like a function of the outcomes. So in general, for example, for the coin tossing examples, your outcomes could be the x1, x2 up to some x10 or x20, something like that, right? So if you tossed a coin n times, then these would be the actual outcomes. And a test statistic is just some function of these outcomes, right? So remember, a statistic is always a function of your observed samples. Okay, the test, and it's called a test statistics because it is the statistic that we are using for hypothesis testing. Okay, so that's the one. So that's the second step. right? It is you measure this test statistic, and and then the third step is that you reject the null hypothesis if the test statistic is in a certain range, okay, and otherwise we just retain the null hypothesis. Okay. So a good way to view this is like saying that a null hypothesis is something that, it's like the default belief. Okay, and you can think of the experiment that you are doing or the outcomes that you see as revealing something about the process, and then you may decide to change your default belief or not. Okay, and some people also, uh, draw the analogy of trying to convince a jury, right, about certain thing. So by default you are innocent unless proven guilty or something, and then evidence builds up, and after a certain level of evidence, then you decide to reject your null hypothesis, which is your default belief. Okay, so that's the other analogy that people often make. Okay, but these are the three steps. Okay, so first you perform the experiment and you formulate these like null and alternate hypothesis. Then you measure some test statistic. Okay, and you reject the null hypothesis if the test statistic is in a certain range. Okay, and otherwise we retain the null hypothesis, which in other words is like saying there is insufficient evidence to reject it. Okay, so so if you are confused about what a null hypothesis should be, I think this analogy of a default belief is the right one. All right, so what does this mean in the tasting tea example? Okay. So remember that there are 4 cups of type A and 4 cups of type B. The lady knows this fact, okay, and then she is asked to identify the 4 that are A and 4 that are B. So what does an outcome look like, right? So I've drawn a very detailed view of the outcomes. Right? So the first is so these the columns here correspond to the true values. Okay, so out of cups that are actually of type A, how many did the lady guess to be of type A? That's written over here. Okay, and how many did the lady guess to be of type B? Okay, so these two numbers have to add up to 4 because we know that there are 4 cups of type A. Okay, so what this means is that she guessed that she had 3 correct guesses and 1 correct guess over here. Okay, and so likewise for B, she of course she knows that there are 4 cups of type A. So if she guessed if she guessed 3 of them correctly, then the one was wrong, right? And that was actually a B. Okay, so that's why this number ended up being 1. Okay, so this number ended up being 1, and of course this number has to be 3 for the same reason. Okay, so that's so this is actually the outcome written out as a table. Right, so now the question could be, okay, so what is a test statistic? Right, so a test statistic is some function of this outcome, right? So the outcome is a certain is this table in this case, and the test statistic, the most natural one you could think of is the number of correct answers. Right, because there's one answer, there's an answer for every cup, and she gets some of them right and some of them wrong. Right? So the number of correct answers is a very valid measure or is probably the most natural choice for the test statistic. Right? And let's call this t. Okay. We've usually been representing statistics by t, and it's a function, and this is now the test statistic, which is the number of correct answers. Okay. Now the question could be, what is now a good test? Right? So remember, a test is basically check if the statistic is in a certain range. Okay. So now you've got to ask yourself, when will I quite likely reject my null hypothesis? Right? So my null hypothesis is that this person is just guessing. Right? And when will I reject this null hypothesis? So if she happens to get like all 8 answers correct, okay, then that is something that we would be surprised by. Right? And that's maybe a good reason to reject this null hypothesis that, oh, okay, she's just guessing. Right? So t being more than some threshold is when you might want to reject the null hypothesis, right? And we need to pick this this threshold appropriately. Right? So for example, you could say that maybe I will see if t is more than or equal to 6. Right? So because maybe you believe that, okay, even getting 6 out of the 8 correct is somewhat surprising to me, so I'm willing to reject my null hypothesis. Right? And now the question, the key question that we need to ask in hypothesis testing is, what is the probability of success under the null hypothesis? Right? So what is the probability that this condition that you wrote down on the test holds, assuming the null hypothesis? Right? So for example, if your test was checking if t is bigger than or equal to 6, right? So you can ask, what is the probability that t is bigger than or equal to 6, assuming conditioned on just lady guessing the answer. Okay. And now note that this is a probability that we can exactly compute. Okay. And this success probability is what we will use to either reject or in some sense to analyze whether this test is a good test or not. Okay. So let's see the computation of this in this example in the next video.